In this video, we're going to look at a brief introduction to surds. I'm going to start the video by drawing two right angle triangles. We'll have one here and then we'll have a slightly smaller one just there. I'm going to put some dimensions on these and find a missing length in each of the triangles. So we'll have 3 here, we'll have 4 here, and we'll put the right angle in. We've got the right angle here, we'll put that this one is going to be 2 and this one is 3. So we'll say that this is x and this one is y. You might already spot that this is one of our triples and you'll know that that is 5. If you didn't, we could use Pythagoras and we could say that x squared, the hypotenuse, is equal to the sum of the two shorter sides squared. So we're going to get that x squared is equal to 9 plus 16. X squared is equal to 25. We take the positive square root and we're going to have x is equal to the positive square root of 25 and x would give us 5. This now is an integer value. It's a whole number, or if you like, a rational number. If I now look at y, we can say y squared is equal to 2 squared plus 3 squared. We can say that y squared is equal to 4 plus 9. Y squared is equal to 13. Taking the positive root, we can say y is equal to the positive root of 13. Now, this isn't going to give us an integer value. It's not even going to give us what we call a rational value. A rational value is a number that can be written as a fraction in the form a over b, where a and b are integers. So this is a rational number. This is 5 over 1. We could write 2.25 as a rational fraction as 9 over 4. We could write 7 over 3. These are all rational numbers. Surds give us now these square roots where we have an irrational number. An irrational number is a non-repeating, non-terminating decimal. We can of course get approximations for them, but what we say is that the surd is in an exact form. So this is the exact value. So we leave it like this. Now if we think about this, we know that the root of 9 is going to be 3, the root of 16 is going to be 4, so that is going to be somewhere in between. Just out of interest, root 2, or the root of 2, is going to be approximately equal to 1.41. The root of 3 is approximately equal to 1.73. These are just approximations. When we're working with surds, we want to keep them as exact values rather than writing decimal approximations. With surds, we can simplify, add, subtract, multiply and divide as you would expect. In this video, we're just going to work through some basic examples of simplifying. In later videos, we'll look at some division, some addition, and then some functional or wordy questions. The first rule that I'm going to introduce is that the root of a multiplied by the root of a will be equal to a. This is something we need to be happy with. It's fairly logical. If we think about this now, if a was 9, the root of 9 times by the root of 9 will, by this rule, give us 9. Well, think about this logically. This is 3, that's 3, 3 times 3 is 9. Therefore, we can see that that holds true for this value right here, where a is a positive number. So root a times by root a is going to give us now a. If we look at another rule, the root of a multiplied by the root of b will give us now the root, and I'm going to write it twice, the root of a times by b, which we could write as the root of ab. We can really manipulate this and split it back up working backwards. And in some of the questions, we will go ahead and do that. So we can work between these. We will look at division later, but a nice little result is that if we have the root of a divided by b, we can write this as the root of a over the root of b. For now though, I want to focus on these first two laws or two rules. These are ones you're going to be have to be comfortable with and work through problems involving them. So let's go ahead and look at simplifying some surds. So we're asked to simplify each of the following. We can break surds down. This isn't yet in its simplest form. So what we want to do is write it in its simplest form. There are a few different approaches that you can take with this, and I'm going to look at some of them. What we could do is look at 8 and think, are there any square numbers that we know that are factors of 8? And the answer is yes, 4. So I could write the root of 8 is actually the root of 4 times by 2. We know that we can split this up and write this as the root of 4 multiplied by the root of 2. So all I'm looking at doing here is simply using this law here. So I'm going to split this up. Now we know that the root of 4 is going to give us 2. So we can say that this is 2 times by root 2, and we say that it's 2 root 2. So our answer is 2 root 2. If we put this in a calculator and we put the root of 8, it will simplify it to the exact value of 2 root 2. So that's one way that you could do it. An alternative is to prime factorise 8. 8 divided by 2 will give me 4. 4 we can divide by 2, and that will give me 2. So as a product of its prime factors, 8 can be written as 2 times 2 times 2. So what we could have said is the root of 8 is the root of 2 multiplied by 2 multiplied by 2, which is going to give us, now splitting it back up, the root of 2 multiplied by the root of 2 multiplied by the root of 2. That's simply using the law that the root of A multiplied by the root of B is the root of A times B. If I look here, I have a pair. Once we have a pair, we know root A times by root A gives us A. So this is going to give us 2 times by root 2, and we say that this is 2 root 2. So our answer is 2 root 2, and that is a different approach. So if we look at this one, we've got the root of 12. So we could spot that that is 4 times by 3. So we could write it as the root of 4 multiplied by the root of 3. We know that this is 2 times by root 3, and that gives us 2 root 3. So that is simplified. Again, if you put that in the calculator, you can have now the root of 12 will give you 2 root 3. As a decimal approximation, 3.46. But if we think about it, if we're working out, especially without a calculator, it's so much easier to leave it as 2 root 3 or root 12. Okay, if I'd gone the other way, I could have prime factored it, so I could have written 12, divide that by 2, then we end up now with 6, I divide that by 2, I end up now on here, and that's going to give me on here, that's going to be, what are we going to end up with, 3. So we've got root 2 times by root 2 times by root 3, so we can write it here that the root of 12 is equal to the root of 2 multiplied by the root of 2 multiplied by the root of 3, which you can see the root of 12 is going to give us 2 root 3. So entirely up to you. If you want to split it like so, that's one way of doing it. With this one here, what we could do is the following. We could write this now, the root of 24, as the root of 4 multiplied by 6. So that gives me the root of 4 multiplied by the root of 6. That's going to give me 2 times by root 6. Now with root 6, I could write this as root 2 times by root 3. But if I do that, I'm not going to have any pairs that are going to give me an integer value, so we would leave it like this. So if I prime factor this, what we'd have is 24. We would divide by 2, that would give us 12. We would divide by 2, that would give us 6. We would divide by 2, and that would give us 3. So if I wrote this out, what we would say now is that the root of 24, so the root of 24 is now the root of 2 multiplied by the root of 2 multiplied by the root of 2 multiplied by the root of 3. Now that is going to give me 2, but then I'm left with these 2 single values. It's only if we have a pair that we can use the property the root of A is equal to the root of A. So I'm going to have to now rely on this being 2 times by 3, which gives us 2 root 6. So as you can see, it does have its advantages going this way. With this one, I've spotted now that this is 4 times by 7, so we could go ahead and use that one. So entirely up to you. I'm just looking ahead of these. I'm going to do this one. This one is quite interesting. I'm going to spot that 25 is in here. So we've got this one as the root of 25 times by 2. So I could write that as the root of 25 multiplied by the root of 2. Root of 25 is 5, so we'd have 5 root 2, and we'd write that as 5 root 2. Now what happens if you didn't spot that? Well, let's do 50. We'll divide that by 2, and that's going to give us 25. Can't divide that by 2, so we can divide that by 5, and that's going to give us 5. So as a product of its prime factors, it's 2 times by 5 times by 5. So we could say that the root of 50 is the root of 2 multiplied by the root of 5 multiplied by the root of 5. We have our pair, that's going to give us 5, so we can say it's now 5 times by the root of 2, or 5 root 2. So either way round, you can go ahead and find that. If we look at this one, that I could think now that 18 is going to be 9 times by 2. So the root of 9 multiplied by the root of 2. This is going to give me 3. 3 times by the root of 2 is 3 root 2. Alternatively, prime factoring it, we can divide it by 2. That gives me 9. Divide that by 3. That gives me 3. So as a product of its prime factors, it's 2 times 3 times 3. So we could write this as root 2 times by root 3 times by root 3. We've got a pair, so it's root 2 times by 3, which of course is 3 root 2, as we would expect. Okay, let's look at another one now. Now with this one, I could see that that's going to be 4 times by 12. Let's do that one. So this one is 4 times by 12. So what we'd have now is the root of 4 multiplied now by the root of 12. I know that this is 2, so I'm going to have 2 root 12. But hang on a moment, I saw that I could simplify this earlier. So what I've got here is 2 times by the root of 2 times by 2 times by 3, which I could write as 2 times by the root of 2 times by the root of 2 times by the root of 3. And of course, that is going to give me 2. So I've got now 2 times by 2 times by root 3, and that is going to give me 4 root 3. If I'd been slightly more switched on, I would have spotted that, hang on a moment, I can write that as 16 times by 3. Well, in that case, I can write it as a root of 16 times by the root of 3. This is a square number, and that would give me 4 root 3. So I didn't spot, and I should have spotted, that 16 went into that. Alternatively, I could prime factor it. 48 divided by 2 gives me 24. I will divide that by 2, and that will give me 12. I will divide this by 2, and that gives me 6. I'll divide this by 2, and that gives me 3. So what I could have done is written this now as the root of 2 multiplied by the root of 2, and I'm just going to bracket that. Then multiplied now by the root of 2 multiplied by the root of 2 multiplied by the root of 3. This is going to give me 2. That's going to give me 2. And then we'll have now 4 root 3. So I'm kind of throwing it out there. You decide how you want to see them. See, this one, automatically, I just think to myself, well, that is going to be the root of 2 times by 100. We could write this now as the root of 2 multiplied by the root of 100. The root of 100 is 10. 10 lots of root 2, so 10 root 2. All of the others should be relatively straightforward. This one's quite nice as well. Let's just look at that one. We've got now 125. Now if I think about this, I could write 125 now as the root of 5 times by 5 because it is 5 cubed. So the root of 5 multiplied by the root of 5 multiplied by the root of 5, that is going to give me 5 root 5. Or if you like, you can spot that this is going to be 5 times by 25. So we've got the root of 5 multiplied by the root of 25, which is the root of 5 times by 5, which is 5 root 5. So yet another way of looking. So all we're looking to do is simplify. Okay, let's move on and look at some others. We're asked to simplify these. Okay, now 2 different ways that you could do this. You could multiply and then look to simplify, or use a bit of logic and simplify first. So I know that the root of 6 can be written as the root of 2 multiplied by the root of 3. I'm then going to multiply that by the root of 3. Root 3 times by root 3 is 3, so we end up now with 3 root 2. So all I've done is said, well, actually we can write the root of 6 as a root of 2 times 3, and there is some clue in the question on how we can simplify. If I look at this one, what I've got now, and I'll do it just here, we've got now the root of 5 multiplied by the root of 5 times by 2. So we could write this now as root 5 multiplied by root 5 multiplied by root 2 which is going to give us 5 root 2. Again, check that on a calculator if you wish. We've already seen that the root of 12 can be written as 2 root 3, so this is the root of 3 multiplied now by 2 root 3. Root 3 times by root 3 is going to give us 3, so we end up now with 3 times by 2, which is going to give us 6. Now that's worked out quite nicely, but let's look if we'd done it another way. I could have done now the root of 3 times by 12. Well, that's going to give me the root of 36. The square root of 36 is 6, as we would expect. If we look at this one right here, we could write this now as the root of 6 multiplied by the root of 2 times by 6. So I could write this as the root of 6 multiplied by the root of 6 multiplied by the root of 2. That's going to give me 6, so we can say it's 6 root 2. Okay, let's do a couple more. Let's do this one here. Okay, this one's quite nice. What we've got here is now 3 root 2. So I'm going to write this as 3 root 2 multiplied by 2 lots, and we've already seen that we can write the root of 8 now as 2 root 2. So I could write it like so. So what we end up with is 3 root 2 multiplied by 4 root 2. 3 times by 4 is going to give me 12. Root 2 times by root 2 is going to give me 2, so this would now give me 24. Let's look at it another way. Well, hang on a moment. Let's write this now as 3 times by 2, so multiplying the integers, and then we're going to multiply the root of 2 times by 8. So this is going to give me 6 multiplied by the root of 16. The root of 16 is 4. 6 times by 4 is going to give me 24. So we can see going that way round, we get now this exactly the same value. Okay, if we look at this one right here, what have we got? We've got 5 root 6 multiplied by 4 root 3. So with this one, what I'm going to do is write this now as 5 multiplied by the root of 2 multiplied now by the root of 3 multiplied by 4, and then we're going to multiply that by the root of 3. 5 times 4 is 20. Root 3 times by root 3 is going to be 3, and then we've got times by the root 2. So we can say that this is going to be equal to 60 root 2. So let's go ahead and check that in a calculator. So if we put this in, 5 root 6 multiplied now by 4 root 3, this should give us now the value of 60 root 2 as expected. So nice and logical and fairly straightforward. Lots of different approaches, you decide. Hopefully you can see now I'm offering it out there of different ways to look at this. Okay, let's look at some more. We're asked to simplify these ones right here. So if I ask you to expand a set of brackets, and I said now x, and then we had x plus 2, we would multiply everything on the outside by the inside. So we'd have x squared plus 2x. What we need to remember as well is that the root of a multiplied by the root of a will give us a. We also need to remember that the root of a multiplied by the root of b will give us the root of ab. And what we're going to do is use that property to simplify these. Let's start with the first one. So all I'm going to do is expand this. So if I multiply these two, we're going to have root 3 times by 2, or I would prefer to write that as 2 root 3. If we now multiply root 3 by root 3, we're going to have root 3 times by root 3. We know that root 3 multiplied by root 3 is going to give us 3, so we would say that this is 2 root 3 plus 3, and that is simplified. Okay, let's pick this one just here. Now what I'm going to do is expand this term by term. So you might use FOIL, first, outer, inner, last. If I did the first terms, that would be 4 times by 1, which is 4. Then I'm going to multiply 4 lots of 2 root 3. Well, that's going to give me now plus 8 root 3. Just think, if I've got 4 lots of £2, I'm going to end up with £8. It's exactly the same as Surds. I'm going to have 1 lot now, so plus 1 lot of root 3. And then I'm going to have now 1 times by 2, which is 2, and I'm going to have plus 2 lots of root 3 times by root 3. So if I look now, I can write this as 4. I've got 8 lots of root 3 plus 1 lot of root 3. Now if I added £8 to £9, sorry, £8 to £1, I'd have £9. So I've got plus 9 root 3. Remember, this is going to give me 3. Root 3 times by root 3 is going to give me 3. 2 times by 3, we're going to end up now with 6. So I could write this now as 10 plus 9 root 3. I've simply added the 4 and the 6. So there we go. Nice and fairly straightforward. Let's pick this one just here. This is written now as 3 root 3 minus 4 all squared. So we need to write it like so. 3 root 3 minus 4. So if I start off by expanding, 3 times by 3 is 9. So we're going to have 9, and then we'll have root 3 times by root 3. So I'm showing full workings. 3 times by negative 4, so we're going to have now minus 12 root 3. I'm just multiplying this term by this one. I'm now going to do exactly the same here. 4 times by 3 is 12, so we're going to have now minus another 12 root 3. And then finally, 4 times by 4 is 16, both negatives, so that's going to be plus 16. So if I look at this now, what I'm going to have here is 3 times by, or root 3 times by root 3, which is going to give me 3. 9 times by 3 is going to give me 27. Minus 24 lots of root 3. So if I've got minus 12 root 3 minus another 12 root 3, that's minus 24 root 3 plus the 16. So we could add the 27 and 16, 43 minus 24 root 3. And again, if you wanted to check that on a calculator, you could. So let's see if it gives us an exact value. So we'll take 3 root 3, we will subtract 4 and we will square this bracket, and hopefully it'll give me in that form. There we go, 43 minus 24 root 3. So there we go. All we're looking to do is simply go ahead and expand. We'll do this one to finish off. This is quite nice. So 4 times by 3 or 3 times by 4 is 12. Plus now 3 lots of root 2. Then we're going to have minus 4 lots of root 8. And then finally what we're going to have is minus root 8 multiplied by the root of 2. If we just look, I'm just going to write this another line. This is going to be 3 root 2 minus 4 lots, and we can simplify this now to 2 root 2 as we've seen in previous examples. The root of 8 is 2 root 2. This is going to give me now the root of 16. The root of 16 is going to give me 4. So if we just tidy this up, I've got now 12 minus the 4, which is 8. Then we're going to have now plus the 3 root 2 minus 8 root 2. So that's going to give me minus 5, and let's just swap this over, minus 5 lots of the root of 2. So our final answer now would be 8 minus 5 root 2. And that's quite a tricky example. So let's just have a look at that on a calculator. It should give us an exact form. So we're going to do 3 minus the root of 8. And we're going to multiply that now by 4 plus the root of 2. So that gives us a nice answer of 8 minus 5 root 2. So there we go. As we expected, we've just gone ahead and expanded it. The level of working will depend on which exam you're sitting. So there we go, a brief introduction to simplifying Surds. In later videos, we will look at adding and subtracting and also rationalising the denominator. But a take-home message from this is that if we have now Surds, these are irrational numbers. They can't be written as fractions where we have the form a over b, where a and b are integers, and we can use these laws to simplify.